Okay, so we've been talking about inverse functions, and today we're going to talk about how to find the inverse algebraically of quadratic functions in square roots. So you saw in your graphing activity yesterday that a quadratic flips on its side, and a square root flips back to half of a parabola. And so we're going to talk about what that means and how it relates when we solve them algebraically. Alright, so fill in your notes on the next slide with the information. Alright, there should be some blanks in your notes. It says, finding the inverse of a quadratic or square root. Steps for solving. So first we do the same thing we did with lines. We switch the x and the y. And then we solve for y. Now in this case, because we have quadratic, which means squared, or square root, which means the radical sign, you're going to either have to take the square root of the function or square the function. And we're going to do some examples here in a minute. Okay, then you need to determine the restrictions to the domain. Okay, so because remember, a negative under a square root is imaginary, meaning it's undefined. So we have to account for that in our solutions in order to make it a function. Okay, so let's do example 1. It says find the inverse of f of x for f of x equals x minus 3 squared minus 5. So this is our equation we're dealing with, and we want to find the inverse. So remember, the first thing to do is write it down using a y instead of an f of x. So I'm going to do that. Then I switch my x to my y. So I'm going to say x equals y minus 3 squared minus 5. Now you're going to work this just like a linear function. You're going to move the standalone number first, and then we'll deal with the square. So first thing I want to do is add the 5 to the other side. Okay, x plus 5 cannot be combined, so it's just x plus 5 equals, now this is still squared, and we keep our parentheses because the entire thing is being squared. Then the opposite of a squared is a square root, so I'm going to square root this side, square root this side. What that does is a square root of a square makes it go away, right? Because the square root of 4 is 2. Same thing, it goes away. And this is going to stay because we can't take the square root of x plus 5. So we're going to have, I'm going to come back up here. The square root of x plus 5 is equal to y minus 3. So once I take the square root, I can drop the parentheses. Then I still want to get y by itself, so I'm going to add 3, add 3. This acts as if it's one thing, so I can't combine anything underneath it, so it's just going to be x plus 5, that doesn't change, and then plus 3 on the outside of the symbol equals y. And that would be your inverse. Okay? So if you notice, we started with this quadratic, right? And we ended with a square root. Well, if you look at your graph that you did yesterday, a quadratic opens like this and then flips on its side like this. Well, we can't have negative solutions, so we only take the top part, which would be the square root function. Okay, so the domain of this one would be restricted to all numbers that don't make this a negative number. So I can't put anything, I can put a negative 4 in there, but I can't put a negative 5. So it would be from negative 5 to infinity for the domain. Okay, or you can include negative 5 because that makes it 0. Okay? So that's what I'm talking about with domain restriction. Alright, let's do a second example. Alright, again we have a quadratic, so we're going to solve it using a square root. So I'm going to write y equals 2x squared minus 16. Then I switch my x and y. Don't forget to that. A lot of you the other day were forgetting that step, and if you don't, then it just doesn't really make any sense. Alright, always move the standalone number first, so I'm going to add 16. So I get x plus 16 is equal to 2y squared. Now at this point, I don't want to take the square root of that because 2 is not a perfect square. So I'm going to divide away the 2 first. Okay, that goes away. So if I come up here, it would be x plus 16 divided by 2 is equal to y squared. At this point, I would take the square root, and I squared that whole entire thing. So this goes away, so I'm left with y, and this is my inverse y, is equal to the square root, it's a big square root, of x plus 16 divided by 2. So all of that goes underneath the radical sign. Okay, so then to look at the domain restrictions, you have to set this equal to 0. So basically you can look at your calculator and do it, but I know that if I put in a negative 17, I'm going to end up with negative 17 plus 16 is negative 1 over 2, so that's a fraction and it's negative. If I put in a negative 16, I end up with 0 over 2, which is 0. So my domain is going to go from negative 16 to infinity. Okay, if you don't quite get how I get the domain, we'll work on that in class tomorrow. But remember, you can always just look at the picture in your calculator. Okay, so that's example 2. Example 3, instead of given a quadratic, we're given a square root. So we're going in the opposite direction. So our solution should look like a quadratic. So first thing, same thing, I'm going to say y is equal to the square root of x minus 4 plus 2. Always move this, or then switch your x and y. So I got x equals the square root of y minus 4 plus 2. Now make sure you're writing your plus 2 on the outside, because you're going to move that first. It's the standalone number. So I've got x minus 2 is equal to the square root of y minus 4. Now, to undo a squared, we square root. To undo a square root, we square it. So I'm squaring this whole entire thing. That's where my parentheses appear. So this symbol and this symbol go away. On this side, you're left with x minus 2 squared is equal to y minus 4. Alright, I'm going to move the 4 to the other side. So my final solution is x minus 2 squared plus 4 is equal to 0. There's a plus 4 over here. Okay? Not equal to 0. Equal to y. Excuse me. I don't know what I'm doing. And that's your inverse. Okay? So, the domain of this one doesn't have to be restricted because it's a squared function, and we know this is a parabola. It opens like that. So there's no restrictions on the domain because it's a squared. Okay, so your domain would just be from negative infinity to infinity. Alright, so when you go from a quadratic to a square root, you have a restriction on the domain. If you go from a square root to a quadratic, there's none. Okay, so make sure you took down the notes on the examples and you filled in the notes on the first slide. We're going to practice this in class tomorrow, so make sure that you do that and you're ready to go. Have a good night.